What are the operations I can perform on this primitive data structure? It includes create, destroy, select, update. What do you mean by complete binary tree? So those are the terminologies which is important. What is child, what is root node, so what is terminal node or leaf node, that and all you have to understand. So here what is the n value? N minus 1 is the value after the deletion. N plus 1 is the value after the insertion. Hello everybody, a warm welcome to one and all. Welcome back to the revision class and most high weighted chapter of your second PUC's computer science, that is chapter 4, data structures. I am Rohini TS, lecturer, Department of Computer Science, Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. We'll see the marks distribution from this chapter. If you study this chapter, surely you are going to get most weighted marks. That is what? You are going to get one question from 1 marks. That will be for 1 marks. No need to worry about the 2 marks question. And when it comes to the 3 marks, you are going to get one 3 marks question. That will be for 3 marks. And mainly you are going to get 3 questions in the part D, that is in the 5 marks question. Totally it will be for 15 marks. So you should never skip any of the 5 marks questions which comes under this chapter 4 called data structure. Totally you are going to get 5 questions from this chapter and it will be for 19 marks. Very, very important chapter and very easy chapter if you have learned all the concept in a good manner. We'll see the first thing which is related to this data structure. So, I just wanted to brief you out the contents of all the contents of this chapter called 4, that is data structure. We'll see the first thing. What do you mean by data structure here? It is a specialized format for organizing and storing of a data. How is the distribution or how the categorization of this data structure will going to take place? It is of 2 types. One is primitive data structure and another one is non-primitive data structure. So under this data structure, we have primitive and non-primitive. Understand? So when I am giving this complete schematic representation to you all, at the time you have to understand. If I say 2-dimensional array, so what and all you have to learn from that? You have to understand what is its definition. Is it going to follow or is it going to have any of the types? And what are the operation it will going to perform? Do we have any other algorithms which is related to this particular topics? That and all you have to concentrate. So that when it comes to the primitive data structure, here it includes integer, floating point, character and pointer. So what are the examples of primitive data structure? Can be as for 1 mark question also. And also when it comes to the non-primitive data structure, it is of 3 types. So what is that? One is arrays and another one is list and another one is files. So when it comes to the first type, that is arrays, in the arrays we have 3 types, that is single dimensional array or 1D array, 2-dimensional array or 2D array, and we have a multi-dimensional array. And this is regarding arrays. So learn the definition of arrays, learn the operations of arrays and learn the algorithm which we are going to deal with this arrays. Along with that, when it comes to the list, again list has been classified into 2 types. One is linear data structure and another one is non-linear data structure. In the linear data structure, we have stacks, queues and linked list. So mainly you have to concentrate on stack, queues as well as the linked list along with this arrays. Then in the non-linear data structure, they are most likely used to ask the question like, mention the non-linear data structure. That includes trees and graphs. And no need to worry about anything with respect to this files. This is the classification of data structure, primitive, non-primitive. Then in the non-primitive, we have list. Under the list, we have linear and non-linear. Under the linear, we have stack, queues and linked list. Under the non-linear data structure, we have trees and graphs. So, what is the first topic here? That is data structure. So that is primitive data structure. It will directly going to operate upon the machine level instruction. What are the example? So when I am describing all these things, you have to understand and you have to analyze. These question can be asked for 1 marks. Like mention the data structure which comes under primitive data structure. So it includes integer, real, logical data, character data, pointer and reference. We'll see the next one. What are the operations I can perform on this primitive data structure? It includes create, destroy, select, update. Everything already we have discussed in the concept class videos. So go back to that and watch all these videos in order to get to know what is create, what is destroy, select as well as update. So these are the operations that can be performed on the basis of this primitive data structure, and it is very important question for 5 marks. Next, we have a non-primitive data structure. So, or complex data structure. These data structures are derived from the primitive data structure. So, in the non-primitive, we have linear and non-linear. So, when it comes to the non-primitive data structure, there we have arrays file as well as the list. So, in the list, we have linear as well as non-linear data structure. Let's see the next topic, that is what are the operations on linear data structure. So when I am talking about the linear data structure, that include stacks and also it includes queue, and then we have linked list. So these are the data structure which comes under linear data structure. What are the operation it can perform then? It can have traversal, insertion, deletion and searching, sorting and merging. So traversal, insertion, deletion, searching, sorting, merging. These are the operation can be performed on this linear data structure. So next we have arrays. So in the non-primitive data structure we have a first type called arrays. So what is array here? It is a collection of homogeneous elements with unique name, and the elements are arranged one after another in a adjacent memory location. Then what are the types of arrays we have? We have one-dimensional, two-dimensional and multi-dimension. Then what are the operations that I can perform on this array? So I can have a traversing, searching, sorting, insertion, deletion, merging. So if I am talking about the non-primitive data structure or a linear data structure, at that time same thing will going to be like a same operation we are going to perform on all those things. So when you are writing the answer for this basic operations on one-dimensional array, at that time you have to write the content with respect to array. For example, traversing, accessing each element of an array exactly once. So inserting in the sense what? Adding a new data element to the array and deleting an element from the array. So in that way you have to answer. But when you are answering it is related to this particular operations of a linear structure, at that time you should not point only on the stacks or queues or linked list. It must be common to all the kind of data structure. Then what is the next thing? We have two-dimensional array. We have one-dimensional, two-dimensional, multi-dimensional. So in the two-dimensional, what you have to learn? Its definition. What do you mean by two-dimensional array? And its memory representation. So that includes row major order and column major order. So you have to understand its location, like how we are going to find the row major order, how we are going to represent the arrays with respect to this column major order. That and all you have to represent with an example along with this particular formula. Next, we have to concentrate on the applications of arrays. On what basis or on what field we are going to use this arrays. That is the application. Understand, application is different than the advantages. So advantages in the sense, from this data structure, what are the benefits I can get? Application in the sense, on what field, on what sector I can use or I can implement this particular concept, that is application. So there is a difference between applications as well as the advantages. So understand with respect to this application, advantages and disadvantages. This is what you have to learn in the arrays topic. And also next data structure is stacks. What do you mean by stacks here? All the definitions are important and all the examples of each data structure is also important. So stack is an order collection of items where the addition of new item and the removal of the existing item always takes place at the same end. Then we are going to call that end as a top. So this will be the stack. If I wanted to add, I have to take a addition of element with the same end. If I wanted to delete, so the operation needs to be takes place from the same end. That is what stack is all about. Next, what are the operations that I can perform on a stack? I can create a stack with the help of the stack functions, and push off item. We can add a new item to the existing stack, and pop. We can remove or delete an element from a stack, and peak. So I can get to know which is the topmost item or an element in the stack. Then is empty. I'm checking whether the stack is full, whether stack has some of the values or not. That is with the help of is empty. And size, that returns the number of elements in a stack. Very, very important question for 5 marks. All these options, all these operations are very important question for 5 marks. Next, you have to be very conscious regarding algorithm for push and pop operation. There will be a chances of asking this question either for 3 or for 5 marks question. Or else there could be a possibility of having a question like what is push operation, what is pop operation with respect to this stack. So learn its algorithm with respect to push and pop operation. Next, what are the application? That means where we are going to use this stack. So in the backtracking, conversion of decimal number to binary, to solve tower of Hanai, and then expression evaluation and syntax parsing, conversion of infix to postfix or prefix, rearranging railroad or course, then quick sort, stock span problem, runtime memory management. These are the applications of stack. It's all about regarding stacks. Then what is the next data structure? We have queues. So here also you have to learn its definition. So what queue is all about? It is ordered collection of items where the item is inserted at one end called the rear end, and an existing item will going to be removed at another end, that we are going to call as a front end. So removal is different in one end and the insertion will be different in another end. It will going to follow FIFO, that is first in, first out. So that stacks will going to follow LIFO, that is last in, first out. So this is regarding definition of a queue. Then what are the types of queues we have? Simple queue, circular queue, priority queue and DQ, that is double-ended queue. So you have to learn the definition of each along with its diagrammatic representation. Then you have to concentrate on the operations of queue. What are the operations I can perform? So I can create a queue, I can end queue of item. So it's same like a push of item. I'm adding a new content to the existing queue. Then we can remove, then we can check is empty, and it also return the size. So 5 operations can be deal with this queue. Queue, end queue of item, DQ, and we have is empty, then size. So then you have to be conscious regarding the algorithm for inserting an element in the queue and algorithm for deletion of an element from the queue. So these are the only possibility of having questions with respect to this queue data structure. So next, also we have applications of queue that include simulation, various features of operating system, multi-programming platform, different type of scheduling algorithm, round robin technique, printer server routines, various application software and operating system. So all these are the applications of queue. Next, data structure is related to linked list. So here also you have to learn its definition, and do we have any other types of linked list, and what are the operations I can perform on a linked list, and should I learn any of the algorithm with respect to this linked list. That and all you have to concentrate on each of the data structure. When it comes to the linked list, it is a linear collection of data elements called nodes, and the linear order is given by means of pointer. So each node contains 2 points. One is fields, so that is the data, and the reference to the next field. So it has 2 fields that includes data as well as reference. This is the definition of linked list. Then what are the types of linked list we have? So we have SLL, DLL as well as CLL, that is singly linked list, doubly linked list and circular linked list. So in this, all the definition you have to learn along with its diagrammatic representation. So next, so some of the operation can be performed on this linked list also. We can create a linked list, we can traverse a linked list, we can insert an item into the linked list, we can delete an item from the linked list, we can search an item, and we can merge 2 or more linked lists. You should never specify only creating, traversing and searching, sorting like that. So what we are searching, what we are inserting, what we are deleting from the linked list, everything you have to mention in a proper manner. So this is regarding what? Linked list. So next we have a non-linear data structure. Till now we have covered regarding linear data structure. Now we have a non-linear data structure. So when it comes to the non-linear data structure, it is only of 2 things, that is related to graphs and trees. What is non-linear data structure here? So a data structure which a data item is connected to several other data items, so that given data item has the possibility to reach one or more data items. But in the linear, it will be in the continuous memory location. But in the non-linear, there will be a possibility of having a connection between one to many. So here, what are the example? Very, very important question for 1 mark question. That is what are the example which comes under non-linear? That includes graphs as well as the trees. So under the trees, under the graph, what do you have to learn? So you have to learn the definition of a tree and types of tree. Like what are the main terminologies we have with respect to this tree. So you have to understand what you mean by root node, what is ancestor, what is descendant, and what is terminal node. What do you mean by complete binary tree? So those are the terminologies which is important. What is child, what is root node, so what is terminal node or leaf node, that and all you have to understand. All the terminologies with respect to tree are important. So when it comes to the trees, so tree is a data structure consisting of nodes which is organized as a hierarchy. It will be like a tree structure only. Then what about this graphs? So graphs is a set of vertices and edges which connects them. So graph is a collection of nodes called vertices and the connection between them called the edges. We have vertices as well as the connection between those vertices will be considered as what? Edges. All these are the nodes here. So then what are the types of graphs we have? We have undirected and we have directed graph. This is the only thing. These are the important topic and this is the content of this chapter 4 called data structure. Let me move to the question section that is related to 1 marks question. So that we'll see the first question. What is cube? Already I have discussed regarding the definition of cube. So this is the content of this chapter 4. So if you learn all these important concepts and if you understand what you mean by this particular concept is all about, do we have any types, and along with the algorithm if you have studied, that will be more than enough in order to get complete 19 marks from this chapter. Let me get into the session that is related to most frequently asked important questions of 1, 3 as well as 5 marks question. What is the first question? What is queue? Already we know the definition of queue. It is an ordered collection of items where an item inserted at one end called the rear and an existing item is removed at the another end called front. This is the definition of a queue. We'll see the next question. Define an array. An array is an ordered collection of items of the same data type that share common name. Next, what are non-linear data structure? Which comes under non-linear? Graphs and trees. And then define sorting. Sorting in the sense arrangement, the process of arrangement of data items either in ascending or descending order. That is related to sorting. So understand one thing, you have to learn the definition of traversing, searching, sorting, merging, insertion and deletion. So that can be with respect to anything. So if they are simply asking what is sorting, at the time you should not write the things which is related to arrays or only stacks or with related to linked list. So you have to write it in a common manner. So sorting is a process of arrangements of an items or a data elements either in ascending or descending order. Next, define searching. So searching is finding the location of a data elements in a given collection of items or a data elements. That is called searching. Next, give an example for non-primitive data structure, which comes under non-primitive. So we have arrays, list and files. So in the list we have linear as well as the non-linear. Next question, give an example for primitive data structure which will directly going to operate on a machine level instruction that includes integer, float, character and pointers are the primitive data structure. Define root node in a binary tree. So when we have a topmost node in a root or in a tree, that will be considered as what? Root node of a tree. Then what is binary tree? So that defines an ordered tree in which each internal node can have maximum of 2 child nodes connected to it. So if I consider this as a node, it can have only maximum of 2 childs. So it can't have more than 2 2 child. So if it is having more than 2 child for a particular node, then we can't consider this tree as a binary tree. If I wanted to consider this as a binary tree, for each parent node or for each root node, it must have only the maximum of 2 node. Next, it is regarding 3 marks questions. So those are related to 1 mark questions, and now we'll see about this 3 mark question. When it comes to the 3 marks question, you must be conscious regarding the algorithms, operations, applications, advantages as well as the disadvantages. We'll see the first question. Write an algorithm for traversal in linear array. How we are going to get a marks in order to get 3 marks in this kind of question? First, you have to write this one, right? What are the data elements that I require when I wanted to perform this traversal? So here my function name is traversal and I have A. So A is nothing but array and I require lower bound and upper bound. So if I get to know what is the minimum value and maximum value, then only I can traverse. Then only I can reach from one node to another node. That you have to mention. So if you are unable to mention this, then you are not at all going to get 1 marks. So if you have mentioned the step, that will be for another 2 marks. You should never miss this portion when you are writing an algorithm. So write what are the content I require. Then mention what are the steps. So here we have 3 steps in the traversal of an algorithm. Next, explain the memory representation of 2-dimensional array. So when it comes to the memory representation, an array. So here I am going to take an array called A, and that has m cross n. It has number of rows and number of columns, and in order to traverse or in order to represent the memory representation of array, it can be done with the help of 2 kinds. That is what we can have row major method or we can have column major method. So then you have to write how will be the construction or representation of that particular data elements of an array with respect to this column major method. So mention what is row major, column major along with one example. Next question, write an algorithm to delete an element from 1-dimensional array. So as I told, first you have to write this. So in order to delete, what and all I require? I require array, I require number of elements and I require item, and I must know the position from where I wanted to delete. So that A is an array with n elements, that is number of elements. Then this item is the element to be deleted. In which position? That is in the POS value or a keyword. So it is stored into variable item. Then you have to mention its step one by one. At last we are going to have exit. Okay. So and you can also expect 1 mark question from this algorithm also. What is that? What will be the n value after the insertion? What will be the n value after the deletion? So here what is the n value? N minus 1 is the value after the deletion. N plus 1 is the value after the insertion. That can also be asked for 1 marks. Next, explain different applications of arrays. That means where and all we are going to use this arrays. So it can be used to implement other data structure, heaps, hash table, queue, stacks, even strings. And also arrays are used to implement the mathematical vectors and matrices, and many of the data structure will going to be based on this 1-dimensional array, which will going to be arranged in a sequential order called records. So these are the applications of arrays. So next question, what is an array, and mention any 2 types of arrays. So if you are writing a definition, 1 marks. If you are mentioning another types of array, that will be for 2 marks. We know the definition of an array, and the types includes 1-dimensional, 2-dimensional and multi-dimensional. Next question, explain any 3 types of queues. So already we know the types of queues. We have simpler queue, we have circular queue, priority queue and D queue. So out of that, you can choose any one of the queue and write its definition and write a schematic representation, how the values or elements will going to be added and it will going to be deleted. So we have circular queue, priority queue and D queue. Out of this 4, you can write any 3 along with the diagrammatic representation. So this is how we are supposed to answer for these kind of questions. It's all about 3 mark question. So in this 3 marks question, what and all other things needs to be covered. So you need to understand the example of each and definition of each. Everything you have to concentrate. So it's all about 3 marks. We'll see the next thing that is related to most awaited 5 marks question. So when it comes to the 5 marks question, there will be a chances of asking operations, there will be a chances of asking regarding particular data structures. So you must be very conscious, you must be very confident enough in order to answer 5 marks question. So you need to concentrate only on the 4 topics here. So understand what you mean by stack, what is the definition of stack, what are the operations of stack, and what are the algorithm that comes under this stack. In the same way with respect to queue. So then you have to understand the same thing with respect to linked list also. And memory representation of two-dimensional array. It can be either with respect to row major or a column major method. And we have 9 algorithms. So if you learn all those 9 algorithms, surely that will comes for 8 marks. Can be as for 3 marks as well as for 5 marks. So there will be a chances of getting complete 8 marks if you study all those algorithms. So that we'll see the important 5 marks question. What is linear data structure? Explain the operation performed on linear data structure. Write the definition and write the operation which can be performed on this linear data structure. Write an algorithm to search an element in an array using linear search method. As I told, algorithms are very important from this chapter. Write an algorithm to insert an element in an array. Insertion, deletion, searching, and we have a sorting. Most likely they used to ask only regarding insertion, deletion, and this linear search or binary search. Next, what is stack? Write an algorithm for push and pop operation. Very, very important question. Write the definition of stack, will be for 1 mark, and if you have written the algorithm for push, that will be for 2 marks, and if you have written the steps for this pop operation, that will be for another 2 marks. We'll see the next question. What are the different operations performed on queue? Write an algorithm for deleting an element from a queue. They are just asking you to mention. No need to explain the operations which will going to be performed on a queue. So write the definition, write its operation. That will be for either 2 or 1 mark. Consider either 1 or 2 marks. So if you are going to write an algorithm for deleting an element from a queue, that will be for 3 or 4 marks. Next, what is sorting? Write an algorithm for insertion, sort. In the same way, searching, binary search, linear search. When it comes to the sorting, insertion sort and inserting an element into an array. Don't get confused. Insertion sort is different. That comes under sorting. Insertion is related to inserting an item into the data structure. Next, give the applications of queues. So already I have listed out all the applications of queues that you have to learn, and write an algorithm to search the elements using binary search technique. Along with this, you have to understand the operations of a linked list, operations of a queue, operations of a stack, and what are the types of stack, what are the types of queue, along with its example and diagrammatic representation. Everything you have to concentrate. 1 marks question, it will be easy. For even 3 marks, you need to concentrate only on all these data structure. If you have studied, surely you are going to get complete 19 marks from this chapter. So these are regarding 8 important 5 marks question. We'll see the next question. What is primitive data structure? Explain different operation performed on primitive data structure. Next, write an algorithm to insert an element into the queue data structure. Next, explain the different operation performed on the stack data structure. All the operations are very, very important. Next, explain different operations on linked list. Okay, it's all about today's session. I hope you all understood. It's all about data structure, that is chapter number 4. I tried my best in order to give the important and most frequently asked question from this chapter. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you very much.